Everyone, welcome back to this channel. This video, I'm going to show you why is it so critical to use the right cable for the measurements. And yes, we understand that there are some cables that can cover a long range of frequency, and there are some that is not. So in this video, I'm going to show you I'm using a very bad cable, for example, a BNC cable that's supposed to work up to at most 1 gigahertz, and I try to measure more than 1 gigahertz of measurements. And what is the risk that I'm taking? So I got this question from someone asking me that if in vector network analyzer mode, the calibrations can remove those error corrections, wouldn't it applicable for cables also? So for example, if I'm using a very bad cable and after I run the calibration, wouldn't it calculate out all the errors that's contributed by the cables and still make my reading correct? I'm going to show you why it's not. Hopefully this will help understand the beauty of RF world. So what you're seeing here right now on the left is a camera that's showing the field box that's connected to a device under test, which is a 6 dB power splitter. So the other end here connecting to a attenuator just to remove the reflections. So on the right, I have this field box that I have set up just now. I'm going to go through step by step on how to run that. Again, I'm going to preset this field box into the default VNA format and walk through with you right now on how it looks like on the setup. So as you can see here, I have port 1 connecting to a BNC cable. So it's just a normal BNC cable and just plug in here. And I try to make it the worst case scenario with the connections. So I have one cables and you can see that there's a barrel that's connecting to another BNC cable. And then from the other end, I'm connecting it to the input part of the power splitter. And one splitter is connecting back to the port 2 of the field box. So essentially what we want is from port 1 and then enter here. And then we do a S21 measurements between the common port and the side port. The other end is connecting to a attenuator just to remove the reflections effect. But this is how it looks like right now. So let's go through step by steps on how to set up the field box to something that we want before you run the calibrations. So we need a S21 measurements, and as you can see here, the cable response is very bad, somewhere right in the middle of the screen. In fact, it's actually starting to deteriorate much from this point. Let's turn on the marker and then we can see where is it all about. The safe region is somewhere here. It's up to 3 gig, and I'm going to turn on another marker. So you can see that here is fluctuating and it's really bad. So we can probably stop about 10 gig ish. 10 gig, 0.2, 3 gig at 0.1. So let's set the start frequency to 10 gig. So you can see that right here is all the jittery region, means that the cable is not really work up to that region, but for the sake of argument, let's put it that way for now. Then I'm going to increase the number of points just to see whether we can increase the resolutions. So it looks pretty much the same with and without the increase of number of points. So the next thing I want to do is change the IF bandwidth to something lower. Say from 10k to 1 kilohertz. Hopefully we will improve the measurements. Not that much. It's alright. So let's say this is what I really want to measure. Let's turn on the marker table so that we can see it better right now. So let's save this trace into the memory so that we can have the comparison between the new data and the memory. So the next thing I want to do is to run the calibrations. Let's go escape. Let's go to cal, mechanical cal. So right now I will select the right ecal that I'm using, so which is here. So the ecal N7555 series, male and female on one end. So how do we set that up? Is we have to go to change device under test connector. So this is my device over here. Sorry, over here. Then port 2 is over here, and then I can swap the gender if I want. So I select the ecal for port 1 and port 2. Let's try again, something like that. Port 2, next. So port 1 ecal, same port 2 ecal. no, sorry, this is forward enhanced response. We're going to change it to 2-pot SOLT, select and finish, full 2-pot SOLT, S21 measurements, pot 1 and pot 2. Same way to select that. Then we're going to start calibrate. Before that, we have to change the connections. So I'm going to do a quick one here. Right, I still couldn't find my top range, but you should use that. So then we can start calibrations. So we connected the ecal between pot 1 and pot 2. And we click measure. So it depends on the number of points and also the IF bandwidth that you set, and it will determine how long the calibration will take place. Click finish and we are done. So you can see that there's some delta into marker 1 and marker 2. It's because of the internal truth from ecal. So what I'm going to do here right now is to do a direct connections to see whether it's more or less flat across it. So it's about 0.5, 0.0-ish reading, which is alright. So the next thing I want to do is to connect the device on the test back to between pot 1 and pot 2. So this power splitter, it's about 6 dB for a pot. Right now we are looking about 6.4 and 8.6 at 10 gig, which makes sense because of the change of frequency. And as you can see, the reading is much better compared to our memory data, which is taken without the calibrations. So the question is whether we can use calibrations to compensate or remove the error from the cables, even if the cable is not built for 10 gig, for example. You can, but with a calculated risk. I think you shouldn't use the cable that is not designed for that frequency. And for this extreme example, I'm going to show you and move the cable right now. You can see that some of the reading is actually screwed up, even after calibrations. So this is an extreme example. Even after calibration, it's not able to remove some of the error at high frequency because that is the characteristic of the cable that will work up to a certain frequency, and after that, it's a calculated risk if you still want to continue to use it. So for this example, BNC cable is not meant for 10 gig. Yes, even after calibrations, you should get a better result, but it's not recommended. So I hope this helped, and this is something that I planned to do for a long time, and finally I got a chance to try out, and it's a good information for me moving forward. So I hope this helped. Thanks for watching.